We talked a lot about even and odd functions and that sort of thing. So the test for that, remember, was plug in a negative x and then see if it changed everything. If it changed everything, then it was odd. If it came back as the original equation, exactly the same thing, it was even. And then we had the symmetry test for even, was if it was symmetric about the y-axis, so you could fold it this way and it match up. And then the origin was folded both ways, this way and then down, and it would match up. That was odd if it was symmetric about the origin. So we had those tests going on. And then we did some, let's see, what else did we do? Even functions, increasing, decreasing intervals, constant intervals, those sort of things. Local maxes and mins, absolute maxes and mins. So we're all of these different pieces of a function and their graph. So what we're going to talk about today is an average rate of change over an interval. So this is kind of like, you know, the local max or min. It was in a certain area. Average rate of change over an interval is going to be, we're looking at a certain part of the graph. Okay, so you may remember what a rate of change is from Algebra 1. Another word for it. Oh. Slope. It's really just a slope is all we're finding. An average rate of change over an interval is the slope of a line over that interval. That's all it is, okay? The kind of collegiate way of looking at that. The notation can get you here. All right, so AB is your interval. Okay, the triangle is the Greek letter delta. That means change in y over change in x. This is your slope formula. No, it's the same slope formula you've been using since 7th grade. So y2 minus y1 over x2 minus x1. So f of b is the y value that goes with the x value b. F of a is the y value that goes with the x value a. Okay. They're not going to give you the two ordered pairs. They're going to give you the interval. They're going to give you the x values. You got to find the y values to go with that, and then use the slope formula to find that average rate of change. And then we're going to use this to do something else called a secant line in just a minute. So really is slope formula is all it is. You just got to do the background work to get your ordered pairs sometimes. So let's look at an example of that. Just call this example A for today. Find the average rate of change for f of x over 1 to 3. Okay. Remember, this is interval. Anytime, let's spell interval right. Anytime we talk about an average rate of change, this is not an ordered pair. It's going to be an interval. That's one of the kind of confusing things here. So people get confused. Oh, that's an ordered pair. Where's the other one? No, this is the interval. These are the x values, 1 and 3. Okay. F of x is equal to 2x squared minus 5x. Okay, so we're going to find the slope of a line between 1 and 3 on the x coordinates. Well, let's kind of discuss, what does this look like? What does the graph of 2x squared minus 5x look like? What is it? Is it a straight line? No, it's a parabola, and it opens up, so it looks like this kind of. Some way it's shifted left, right, up, down sort of thing, but it's a parabola. So we're finding the slope. The slope is with a straight line. So we're finding the slope of a line, even though our function is not a straight line. Okay, so we're just finding the slope. If you drew a line between the ordered pairs that go with these x values, we're finding the slope of that. That's what we're doing here. Okay, so what we need to do here is find f of 1 and f of 3. That's gonna give us the ordered pairs that we need to use to find our slope. Okay. Okay. So whatever the endpoints of your interval are, you're going to plug those in and get the y value that goes with that. So 2 times 1 minus 5 would be -3. And f of 3 would be 2 times 9 is 18 minus 15 would be +3, right? Okay. So ordered pairs, if it helps you to write them as ordered pairs so that it's more 1 -3 and 3 +3. That's our ordered pairs that we're using to find the slope. Maybe that helps you.
So you just take the first one, the one that gives you the first one, and put it with the got.
So the x value 1 was the x value here. I worked that out and got the -3 as the y value goes with it. And then 3 is the x value. I worked it out and got +3 as the y value goes with the x value. So it creates these two ordered pairs. And then we just use our slope formula. y2 minus y1 over x2 minus x1. And I'm not picky about you if you use the delta y over delta x. That doesn't matter. M is fine for slope because we're going to use that in just a second. So take your y values, 3 minus -3 over 3 minus 1. So that'd be 6 over 2, which is 3. So the average rate of change is 3 over that interval. The slope of the line, technically, that connects these two ordered pairs is 3. Yeah. No, you don't. The ordered pairs are just how we get there. 3 is the answer we're looking for. Okay. So it's just plugging stuff in and working from there. It's not necessarily incredibly difficult. So let's take this idea. We're going to do some more with it. We're going to take and find a secant line. And in geometry, I'd say you talk about secant lines. You may have talked about secant lines. What's a secant line and a tangent line? What's the difference in those two? You might remember. Well, that doesn't mean you couldn't know this. No, that's what term is. No, not necessarily. A secant line intersects a circle. A tangent line does as well, but what's the difference? That's it. No. Secant does it twice. Tangent does it once. But they do intersect circles.
Is it like diameter or radius?
Well, no, a diameter of a circle would be a secant line because it intersects the circle twice. So what we're looking at is a secant line of a graph, not necessarily of a circle here. When we say secant line, it intersects it twice. How many ordered pairs did we find in that first example? 2. That's our intersection points for a secant line. So we're going to use that idea. So we're just going to take this problem right here and extend it to example B, and we're going to find a secant line over the interval 1 to 3 for f of x equals 2x squared minus 5x. So it's the exact same problem. We're just extending it. Okay? Now, A and T. S-E-C-A-N-T. Secant line. If we're going to write the equation of a line, what form do we want the equation of a line in? Which is? Yeah, that's the form we're going for. Several different ways to get there. I'm going to go my direction, and then we'll talk about the other directions that you can go. I don't care which way you get there, as long as you get there. Okay, secant line. in slope-intercept form. So it's an equation of a line. So that's what we're looking for, okay? So here's the thing that we've got so far. We've already found the slope, the average rate of change. So we've got M. We need to find B. We've got two ordered pairs. We can pick one of those to use to find B, okay? Now, the way that I do this and the way I teach it in Algebra 1, and if you had me for Algebra 1, you probably remember this. I do y minus y1 equals M parentheses x minus x1. Point slope form and then plug it in and get y by itself is what I do. So we already know the slope is 3 from example A, because this is the same problem, just done, extended into the secant line idea. We have ordered pairs to use. Okay, I've got two ordered pairs. I've got 1, -3, and then 3, 3. It does not matter which one you use. Pick one. I'm going to pick this one just because it's the first one. It doesn't matter which one you pick. So I'm pick one of the ordered pairs that I found for that interval. Okay, so y minus -3 and then x minus 1. And then get y by itself so that it's in slope-intercept form. Okay. So that'd be y plus 3 is equal to 3x minus 3. And then subtract 3 again. 3x minus 6. There's our secant line over that interval from 1 to 3. We found the slope, the average rate of change, by finding two ordered pairs. We use that slope and one of the ordered pairs to find that equation of the line. Now, if you didn't do it like this in Algebra 1, that's fine. You could have done it, you could have just taken, this idea, and some of you may have done it like this in Algebra 1 and solved it for B. So you got -3 is equal to 3 plus B, and you subtract 3, and B is equal to -6, just like it is in my equation. It doesn't change anything. That's still going to be y equals 3x minus 6. This is how I have my students do it in Algebra 1. Y'all may have done it this way. It works the same. Okay? Find the equation of the line. You got the slope from the average rate of change, and then you use one of the ordered pairs to find the slope, the y-intercept of that line that intersects that graph. Okay.
You have to use the lines.
You have to use one x and one y from the same ordered pair. It doesn't matter which ordered pair you pick. So let's look at another one and see if we can do the whole thing for it. Okay. Let's say we have f of x is equal to 3x squared minus 2x plus 3. So I'm picking, it's a parabola. It's not a straight line. I'm just picking a function there that I know a little bit about. Not necessarily that it's important that I know much about it. But we want to over -2, 1. So instructions I didn't write here. Find the secant line. Four. And then that. Okay. So finding the secant line, kind of vague instructions, but we should kind of learn a process of how to go here. What's the first thing that we should do? Before we can find the slope, we've got to find the ordered pairs that go with it. Right? So we're going to plug in what for x? -2 and 1, you mean? Yeah. So these are x values because this is an interval. They're given, this is x1 and this is x2. It's an interval. Okay. So I'm plugging that -2 into the function they gave me and working it out. Ever how you do that, if you do it with a calculator, that's fine. Whatever you got to do. So that's going to be 3 times 4 is 12, plus 4 is 16, plus 3 is 19. So that gets us the ordered pair -2, 19. And then I plug in f of 1. Work that out. Just a little easier to work. 3 minus 2 is 1 plus 3 is 4. So that gets us the ordered pair 1, 4. Okay. Once we get the two ordered pairs, the next thing to find is what? The slope or average rate of change. Okay. I'll try to refer to it as average rate of change, but we know it's a slope, so don't let that confuse you. Okay. So the slope, 19 minus 4. And it doesn't matter what order you put the y values in as long as the x values are in the same order. And so I'm going to put negative 2 minus 1. So it'd be 15 over negative 3. It should be negative 5 if you do the slope correctly. So there's our average rate of change, or our slope. What's next? Okay, and find the b, the y-intercept. Okay, so pick one of these ordered pairs. I'm going to kind of lean toward this one because it's smaller numbers, right? I don't want to have to, get something with 19 in there. 1 and 4 is a little easier. So ever how you do that, I'm going to go my direction. Y minus 4, negative 5x plus 5, and then add 4. Y equals negative 5x plus 9. Whatever direction you go in to get that slope-intercept form, the slope is negative 5. Now, for here, we're distributing. So negative 5x and negative 5 times negative 1 is positive 5. So I'm using point slope form to get there. If you want to go the direction of doing this, y equals, negative 5x plus b, and then plug in, 4, negative 5 times 1 plus b, it's the same amount of work. It's not any less, honestly. So that'd be 9 is equal to b, and then you got to rewrite the question. No, that's fine. I don't care which direction you go. I do it this way just because that's a habit I'm in, and that's the way I teach it in Algebra 1, and Algebra 2, and geometry, and everywhere. But it helps me because what if they ask for the point slope form of an equation? I have it. Because they could. Not necessarily that they will. They normally are going to ask for this. That's the normal way of asking for that answer.
So that
This is the secant line. That's the equation of the secant line. That's exactly what that is. So these are the equation of the secant line. That's what those are. Equation of the secant line. Average rate of change is what? Slope. Secant line, you're going to use average rate of change and then one of your ordered pairs. Doesn't matter which ordered pair you pick. Pick one. Pick the one you think is the easiest and then work from there. Okay? Questions about this? All right. Not too daunting. It's really a lot of Algebra 1 stuff. You may not have done it in a while, but it's a lot of Algebra 1 stuff there. So in addition to page 237, 1 through 59, if you'll just go on through 79, I believe is right. Yeah. Yeah, I would do the odds. And then if I have trouble with those, maybe do the evens beside them, and that way you get more practice with that. If you can do the odds and check those and you're doing fine, then that's, I would say, plenty of that. Okay.
Are we gonna have